In this video, we're going to be talking about spontaneous processes. Spontaneous process is a physical or chemical change that occurs by itself. So we're going to watch this video, and in this video, what's happening is the barium hydroxide octa water plus ammonium chloride is reacting to form barium chloride di water plus 2 ammonias and 8 waters. Okay, so I already have it queued up here. Okay, so this was an endothermic process, but it was also spontaneous. They didn't have to do anything for this reaction to go forth. And so it was able to freeze the beaker because they put water down on the board. They were able to freeze the water between the beaker and the board to make a seal while that reaction was undergoing. So entropy S is basically the measure of the randomness of disorder, and one of the two components, heat, is one component, and entropy is the other component into whether something is spontaneous or non-spontaneous. So entropy is the term that we're going to introduce, is basically a measure of the randomness or disorder in a system. One of my favorite quotes from the original Jurassic Park is that when they're being chased by a dinosaur, the mathematician talks about the fact it's not going to end well because chaos in the universe is always increasing, and that's true. The units for entropy is joules per Kelvin, so there's a temperature component there, and it's a state function, meaning it doesn't matter how you get there. So because it's a measure of disorder, the solid of a compound is going to have the lowest entropy, followed by that of a liquid, because it moves some, and the highest entropy of a compound is going to be in its gaseous forms. So the second law of thermodynamics says that the total entropy of its system and surroundings is always increasing for a spontaneous process. Entropy of the universe therefore is always increasing. And then the change in entropy is the entropy plus the heat per absolute temperature. Okay, so for spontaneous, the change in entropy is going to be greater than the heat divided by the temperature. So this shows here a spontaneous versus a non-spontaneous process. If I blow up a balloon, a regular latex balloon, even if I don't put a hole in it, if I just leave it sitting, it's going to naturally deflate. Okay, so that's a spontaneous process. However, a deflated balloon is never going to spontaneously blow itself up. Okay. Entropy change for phase transitions is at equilibrium, so it's equal to the heat divided by the temperature because there's no heat flow. And so for a spontaneous process, the delta H minus T delta S, okay, is less than 0. Okay, so the spontaneous process, the sum of these two are less than 0. And so this is showing here the fact that basically condensation from a gas to a liquid is an exothermic process, so it's negative. Okay, it's also a negative entropy because of the fact I'm becoming more organized. And so here's this phase over here, this same image from over here. Okay, from a liquid to the solid, the same thing. I'm losing energy, heat's leaving the system when I go from a liquid to a solid, and it's becoming less chaotic, so delta S is also negative. And from a solid to a gas, now all of a sudden I'm going from this to this, so it becomes more disordered. And I also have to have input of energy, so it's endothermic. So therefore this one's positive and this one's positive. Okay. And so that's how these things go apart here. And that's going to be the end of